a little bit of introduction. This is Suntrack by P4Q. Many of you know us from a lot of years. Others are new to us, but all of you are welcome. So this is Gorka Alapont. I'm key account manager for Europe for solar business. And this time we are introducing the new product that we have recently launched. It's called the DCU, Distributed Control Unit. So let's go for it. So it is clear that we have a new trend in the PV industry. Modules are getting bigger and bigger. Some people call them extra large modules. And then tracker manufacturers need to redesign their structures to host those large modules, right? So obviously mechanical stability is not the same when you increase module size, so that needs to be taken into account. One way of keeping good stability, from what we've heard, we are not experts in mechanics, you are the experts, is by using multiple drives, right? If you want to stay, if you want to keep the tracker as long as it used to be, and you want to keep it as rigid and robust as it used to be, you need more fixing points. So adding multiple drives is a good way to do that. This is what we have seen so far. Other way is using transmission mechanisms such as cardans. That could be a solution, but are often expensive and require higher maintenance. And we have the problem of not having torsional feedback at the edges of the tracker, right? So we could end up with a tracker that's 0 degrees in the middle and then maybe have 10-15 degrees at the end of the tracker. So that's a huge problem. So taking these requirements into account, we thought that trackers require a robust and stable control unit capable to manage a multi-drive tracker in a cost-effective way. And that's why we are launching the DCU, to allow multiple devices across the axis of the tracker, or even having 2 rows of tracker in a main secondary configuration. Okay. So product overview. If you see the picture on the right side of the screen, you will see a 3-drive tracker structure. So we have the central pile and the central drive that will host the main controller. So this can be either can be powered from the string itself or from the grid, AC powered. So both options are available in this new DCU. As I said, the main DCU is similar to the DCU you are used to from many years ago, obviously with the new evolutions and new functionalities that we are adding. And then we have a bunch of secondary units that are powered from the main unit through a PLC communication. So both power and communication are transmitted from the main to the secondary device. For that, as I say, we use PLC communication, and this is done through standard PV cable of 4 millimeters section with PV connectors. So no need for RS-485 wiring. So then this is flexible and scalable. So this is not the only configuration we can use. It's open to different types of sensors, devices, and even human-machine interfaces. Communications are reliable at tracker level, thanks to the PLC. So no extra cybersecurity requirements, because everything is done locally. Then it's inexpensive and easy to install compared to mechanical transmissions. This is just connecting a common PV cable that's really common on site, and just crimping the MC4 connectors or PV compatible connectors from the main device to the secondary devices. All right, so the concept and philosophy that we have of plug-and-play devices, it's still present in this solution. All right, so I was talking about multiple configurations that we can have with the same technology. So first, the obvious one is the first one you see on top. That's what we call the tracker master unit. This is the typical use case of a multi-drive tracker with a center pile with 1 slew-in drive and 2 secondary slew-in drives, or even 3 slew-in drives. Second one is having inclinometers at the ends, so that we can have the torsional feedback of the structure, so that we can know, even if we are not moving in multiple points, we can know whether the tracker is it's moved and it doesn't have the same angle as in the central pile, so we can know that. We can also include electro valves and remote locking units. So instead of having a motor, we can power and control a locking device unit. And then finally, we can also have a ground level interface for use cases such as agrivoltaics, where operation and maintenance is really hard to perform at 7 meters high. So going into deep into the technical data, we are distinguishing two applications. One is the multi-drive single axis, and the other one is the virtual dual row, as I like to say. So as I was saying, the input type is either string powered with or without battery backup, or AC powered. We are not using self-powered in this DCU version. Okay, it's important to bear in mind. We have two movement options depending on the current demand of the power demand of the drive. So if the combined demanded power of the three drives is less than our main TCU capacity, we can move them at the same time. If the capacity is not enough to move the three or two drives at the same time, we can move them sequentially with a new dedicated algorithm. Okay, always taking into account that we cannot exceed a torsional limit, and that is obviously configurable from the customer side. So the communication between the main and secondary devices is PLC, power line communication, but the NCU main device communication is still ZigBee, and obviously ZigBee with encryption to meet with cybersecurity requirements. So for multi-drive single axis, we do have independent row backtracking, including the new 3D backtracking algorithm that we will present tomorrow at 3 p.m., I believe. But the bad thing is that for the dual axis, the virtual dual row device, we do not have independent row backtracking yet. We do have overcast and ISTO algorithms as the usual algorithms that go within the standard TCU. And for a multi-drive single axis, one main device can control up to 3 devices in the same row. And for the dual row device, one main device can only control 1 secondary device. Okay. So in case you have any more doubts, you wanna get a brochure, we have our media center back there, or you can contact any of our team members for more information. Okay. It's basically a brochure or a data sheet that you can share with your customers too. As I was saying, all advanced algorithms that we have recently launched are available with this DCU. 3D backtracking is obviously available. ISTO for configurable angle restrictions to improve your defense strategy, that's also available. Overcast and winter mode are available too. And finally, the dynamic limits that we already have in the standard TCU are obviously available too. So a little case study, because this is a new product, but it has already been commissioned in several PV plants across the world. A couple of them have been commissioned in Spain, but since two of our colleagues had the chance to travel to Hawaii, we thought it was cool to show it off. So this is the Kauai PV plant located in Hawaii, the US. It's a 25 megawatt plant, and it's a tracker configuration of, it's a 2P, 80 meters long, and it has 2 slewing drives. So he's laughing because he's a friend of the guy in the picture. So it has 2 slewing drives, so the configuration we used in this one is a main device and a secondary device, and they both move simultaneously. So there's no risk of torsion at all. And this was commissioned during early May, and it's functioning, working, and no problem so far. All right, so this was it. If you have any extra doubts or questions, don't hesitate to reach out to us, and hope you liked it.